How's it going, everyone? Okay, so today we're going to be going over AMD's 192 core CPU, and this is their EPYC 9000 lineup. Okay, here we go. So this is the AMD's EPYC 5th generation AMD EPYC processors, advanced in AI cloud and enterprise computing. So we're gonna go over the demo on this too. So this is introducing 5th gen AMD EPYC processors, purpose-built to accelerate data centers, cloud, AI workloads. The AMD EPYC 9005 series of processors are driving new levels in enterprise computing performance. So this will be a very, very, very good CPU for people that need older core, especially for, AI workloads again, cloud centers, and just accelerated data centers. So basically all the workstation type people would be interested in this, especially if you do any of these kind of things. So we'll go into the demos. End-to-end AI based demo. So it's much, much faster. It does have a lot of cores though, so it probably will help. Of the 3.8 times AI throughput. Crazy. So here's a good spot. AMD EPYC 9005 processors for deep learning and generative AI. Up to 192 Zen 5C cores for compute-intensive AI workloads. 576 gigabits per second socket memory bandwidth for small to medium gen AI models. Full width AVX 512. Data path for hardware accelerated deep learning, which is great. Great to see. And we'll go generative AI. So it's very fast. Throughput tokens a second, 73. So input tokens 120, output tokens 128. So comparing through the 2P Xeon Platinum, 8592 plus. So throughput tokens per second is 102.8, which is good. You cannot really complain about that. Throughput tokens a second for the 2P EPYC 9965 is almost twice as fast, which is insane. Let's translate. So this isn't hardware accelerated at all. This is strictly CPU. This is strictly CPU, which a lot of people would be doing these kind of things on GPU, but this is on CPU side, which can be done the same way as the GPU, of course, but instead of it being GPU accelerated, this is strictly done on the actual CPU itself, which is insane to see. So throughput tokens a second is 93.6 for the Xeon Platinum 8592 Plus, and the 2P EPYC 9965 is 177.6, which is very, very fast. Almost two times fast. Yeah, essay as well. What's we at? So summary, 1.82 times faster. Chat box is 1.9. Translate is 1.9. Essay is 2 times as fast, and caption is 2 times as fast, which is great. Like that's actual performance. Machine learning, AMD EPYC process for GPU host. That would be a good one for people to know a bit about too. So GPU accelerated AI. So this is GPU accelerated AI training for performance. AMD EPYC 9575F, AMD Instinct MI300X, and Intel Xeon 8592 Plus. Average 1.22 times AI train throughput, stable diffusion, XLV2. So again, GPU accelerated AI interference performance. So we got AMD EPYC 9575F, AMD Instinct MI300X, Intel Xeon 8592 Plus, and AMD Instinct MI300X. So Llama 3.1-70B FP8. Averaging 1.08 times AI interference throughput. So Llama 3.1-70B FP8. They are putting out some numbers. Visual database, relational database, and energy efficiency is one thing that AMD has been good for. So we'll see how good their efficiency is on this. Server-side Java energy efficiency demo based on S-Spec power. Java is one of the most widely used server-side. So Java is one of the most servers. Java is one of the most Java is one of the most widely used server-side programming languages. Server Java workloads are both compute and memory intensive. Power is one of the biggest challenges of every modern data center deployment. Energy efficient server CPUs help improve total cost of ownership. So a lot of these big companies that have data centers and stuff like that, they have a capped off wattage limit that they're allowed to use daily, weekly, monthly, yearly, that they are capped off on how much they are actually allowed to use, depending on the region that they are in. So it all varies off. I can get more information on that if you would like to know more about different places of how much power you're allowed to use in a data center, weekly, monthly, or yearly. Let me know in the comment section below, and I'll make a video about what parts of the world are allowed so much wattage in different kind of regions, and let you know about that, because efficiency is key for these companies, as they may only have such a big factory or warehouse full of this data centers where they're only allowed so much wattage. So they'll continuously update their data centers so that way they have the most efficient, so that way they can continuously put in more units and save themselves some money and power. Server-side Java energy efficiency is, so this is versus 2P AMD EPYC 9965 and 2P Intel Xeon 8592 Plus. Okay, so to hit this same Java ops of 150B, the idle wattage for the AMD EPYC 9965, this was idle wattage, 159 watts. Pretty crazy. So seems high for an idle wattage, but these are multi-cored CPUs. And they do take a little bit of power. They might not use a whole lot of voltage to allow it to have that much wattage at idle, which will allow it to keep it idle for low wattage, which is really good to see. Java ops is 150B. Idle for the Intel Xeon 8592 Plus is idle watch is 166 watts, and the kilowatts an hour is 1.73. So it is quite a bit more for the Intel Xeon. Does use a bit more power, so maybe a lot of these data centers will be switching over to AMD for some of their AI platforms. 1.73 times server side Java energy efficiency. So it's really good. AMD EPYC 9005 processors for server-side Java workloads up to 192 Zen 5C cores for compute-intensive workloads, leadership server energy efficiency for resource optimizations, 576 gigabits per second socket memory bandwidth for memory-bound workloads. And having efficient CPUs is what data centers really need, especially when AI has taken over and absolutely hit the market and people are using it, not in just us consumers, as in us individual people have been using. Big companies are using AI as well, as in they are implementing AI into like their robots. Car manufacturers are using it as well, like Mercedes. Tesla has their own. There's so many different kind of AI workloads that need to be done, and having these big data centers will help speed up the process of AI workloads, which is absolutely insane. Again, you got like Chat GPT, deep learning, and stuff like that as well, which is absolutely insane for how many users are actually using that kind of AI. So great to see that they are making an efficient CPU for AI, like AI based for all these AI and ML. That's crazy good. 192 cores though. So we're gonna go over this page too, which is Windows. Microsoft Microsoft has revealed Windows Server 2025 CPU support list in conjunction with the operating system's general availability, which was announced today. CPU support includes chips such as Intel's flagship 64-core Granite Rapids and Emerald Rapids chips, down to surprisingly Intel's consumer-based entry-level dual-core Pentium parts. Intel's CPU support includes several generations of Intel Xeon processors. These are the second through fifth gen Xeon SP CPUs based on the Emerald Rapids, Sapphire Rapids, Ice Lake, and Cascade Lake architectures. The Xeon D series, which is also based on the Ice Lake, the Xeon E series, which is based on the Raptor Lake, and Intel Xeon 6 series, which is based on the Granite Rapids. Surprisingly, two Pentium branded processors make it into the list, the G7400 and G7400T. These are old Alder Lake based dual core consumer chips aimed at the entry level desktop market. Both chips come in with just two P cores and 4 threads, with the G7400 operating at 46 watts and G7405 74005 at 35 watts. It is a mystery why Microsoft selected these two CPUs specifically. Perhaps these chips provide the bare minimum amount of feature support server 2025, but we cannot be sure. These chips, yeah, again, as they said, Alder Lake, LGA 1700, and they also have like the G6900. These two core CPUs are really good for overclocking. They're two cores, yes, but for the two core category of overclocking, these CPUs are very, very good. Like top of the line for overclocking, for a low wattage CPU too, and you don't really need to chill it down as much as you think to get the core frequency up, which is absolutely amazing to see too. And we can go over some records too on these two core CPUs if you'd like to see. Just let me know in the comment section below. So Windows Server 2025 CPU support list. Intel CPUs. Second through fifth Xeon SP processors, so whole bunch. AMD EPYCs, the 7000s, 7002, 7003s, EPYC 4004, AMD EPYC 8004, AMD EPYC 9004, and AMD EPYC 9005, which is their top of the line EPYCs. So like their 128 to 192 core CPUs. On the AMD side, Windows Server 2025 supports all of AMD's modern EPYC-based CPUs from Zen 2 to Zen 5. It features the AMD EPYC 7002 series, 7003 series, 4004 series, 8004 series, 9004 series, and 9005 series alike. Unlike Intel's support list, Microsoft did not test any mainstream consumer Ryzen processors, which is just fine. It's just fine. These are It is for Windows Server and not everyone, consumer, not a whole lot of consumers are going to be running on Windows Server 2025. And we'll be using these Ryzen processors. They'll be using like these EPYC or Xeons as well. Or like they said, the Pentiums as well. So, however, Microsoft notes that the list of supported processors above does not determine the actual support. The list is a mere prerequisite for the system certification, meaning that only systems with the above CPUs can be certified to run Windows Server 2025. These CPUs won't be the only ones certified either. Microsoft will update the list with future CPUs as time passes. Of course, things take time to add in. Just to add in. It does take time to add stuff in, and they're not going to put all the resources just to add in a whole bunch of CPUs that people will probably not be using on Windows Server 2025. So Windows Server 2025 general availability just went live, and it will be supported for the next 10 years. The new server focused OS includes many under the hood upgrades and features such as accelerated I/O throughput, performance, GPU partitioning, and VBS enclaves. Nice. Well, AMD's got a good road ahead of them for Windows Server 2025 at least, so that's really good. And hopefully Microsoft Windows is going to keep up the word. For 10 years it's going to have support on just Windows Server 2025, which again, anyone that's going to be running like this kind of Windows Server, depending on the person. If you're this kind of person, let me know in the comment section below and what you use for your PC hardware and what maybe you use your PC hardware for, so that way people can get a little bit more detail on what Windows Server 2025 is really about and what Windows Server type Windows is actually about as well. Most people are running on Windows Home or Windows Pro, which is Windows 10 or Windows 11. Most, or if not all, of CPUs are now allowed to be running on Windows 11. It's not really recommended if you have under 16 gigabytes of RAM to be running on Windows 11. So I would suggest just sticking to Windows 10 if you have just 16 gigabytes of RAM, as it can slow down the actual processing power of the CPU. And just overall will make things a bit quicker if you just stay in Windows 10. But yeah, that's all the news for the 192 core CPU. I'll keep updating anyone that would like to know. If you want to join the Discord channel, just click the More tab, click the Discord link, and it'll bring you to the Discord channel. There's a whole bunch of channels in the Discord, and we go through PC hardware, overclocking, and PC news there, and just general discussions as well. So let me know in the comment section below on whether or not you like this video or not. Would like to see more of these updates on CPUs, and whether or not this 192 core CPU is really going to be worth it for any daily users or anyone consumer or person of single person, not data centers or anything like that, to actually use this CPU, because it will not be a cheap CPU. It will most likely be a $10,000 CPU. I can update some things in the Discord about pricing if you would like. Again, just let me know in the comment section below. So again, thank you to anyone watching this video, to watching my videos, subscribing. You guys are awesome. Again, thank you to all my viewers, subscribers, and donators. You guys help out this channel greatly. So hopefully we can keep this going, and hopefully AMD can keep up their good work on keeping nice efficient CPUs for everyone. As always, don't forget to get her done.